A few. Okay. Quite a few. You guys know what to do. If you're not checking it now, you're checking it later. So, number 2. Wise. Number 2. I'm very proud of you guys. Number 2 is 20. Number 4 is 42.5. Gallons have entered the pool. Sounds like a velocity to me. Not velocity, a volume. Number 8. Oh, you see the other one? Struggle. Can I do this and make it a little bit bigger? There we go. Remember, RRAM starts for the right Riemann approximation. The MRAM stands for the midpoint approximation. So you have 1.25 and 1.375. So you could have used the summation technically, right? And simplified the process, but this is if you did use the plugging in method. Katrina.
So for right, is it like you're coming from the right or you're going to the right?
Means that when you look at it at a given subinterval, like right here to right here, your height is determined by the one on the right.
So you come from the right?
Yeah. Does that make sense? Subinterval coming from the right. But it's not just from the right, it's hitting at the right. So you can think from the right, you can think hitting at the right, either way. Midpoint, there we go. Number 20. Left Riemann approximation. How did they make that look so stinking easy?
They left out a lot.
They took out a 10, basis times heights, and how did they get all of those values? What was given to you, number 20? A function or a table? Exactly. Remember on charts, if you're coming from the left, first of all, you have to test all the subintervals. Are they usually on the AP equal and they're all equal to 10?
No, not.
No, that's usually like different widths, right? Different bases, so be careful. But since all of these were 10 and you were able to start at the left, take 0 all the way to 1 away from the end. The other one would start at 44, go all the way to the end of B. Right, start at the right endpoint, left, start at the left endpoint. Average, oh, you just add the two together, divide by 2. Do you guys have a question?
No, ma'am. Perfect.
Kyle and John, do you have a question?
I'm just trying to figure out what I did.
Oh, okay.
Do you wrote them in order?
And then kiddo, same thing with number 26, simplifying. Don't do a decimal.
Oh, don't?
Oh, you can still see it?
There's a left one, there's a 0 here.
There you go. 26, 32, and 36. All the answers are on the board. Hold on, pause and grade.
Sorry.
This is going to be gone in a second.
Yeah.
Pause and grade.
Disagree.
It's over here on the left.
Can you take a test in here?
Thanks for asking. Yeah, I
I thought she had a bracelet in there. I'm going to go to dress room. Yeah. Mr. Kim told me this morning, he was like, take off your hat. And I was like, okay. And then I just went to class because it was in the middle of class. And then I was like, okay. And then I just never took it off because now I have hat head. And so Mr. Halliday saw me in the hall and I just went like this. Because I'm stupid to try to cover the no symbol that I have. Oh my god!
Katrina, if you want any point to go in the back, you can take it off. You can like whoosh, whoosh, whoosh your hair and then just let it go.
I put the hat on for a reason.
All right, kiddos, is that all the evens?
Yes, ma'am.
All right. Here we go. Section, well, hold on. Any quick questions that you guys got lost on or stuck on? Evens or odd chapter? Alan, what do you got?
8.
8?
Just the RN. Just the RN.
Okay, just the RRAM on 8. Anything else? Yeah.
17.
Okay. Anything specific or the whole thing? Okay, John?
I just had a question because I didn't see if 36, what the answer to 36 was.
Oh.
18.
Okay. Thank you.
Okay, really quickly, guys. Today is minimum day. We've already talked about, I don't know, life, class, something, considering others. Let's go ahead and just go peek at this really quickly together. So numbers 8 and 17, let's get rid of our circles because we don't need them anymore. Oh, hi, book that's not showing up. There we go. All right, as I get that up and ready to look at number 817, you guys can start writing what you need from the introduction of the definite integral. You can keep your spiral out, though, if you need to look at 8 and 17. Hey, look, Leibniz notation. He's the one that came up with an integral? Yep. Because he took an S for summation and made it long and skinny, literally.
Wait, that's what he did?
He took an S for summation and made it long and skinny.
How you like this?
Muy interesante.
If you don't, it's okay.
What are we on? Chapter 6. Section 1. Alan, it was 8 and 17, right?
Yep.
Okay, 8, the right. And 17.
What is K equal to?
K is usually constant.
1.
1 to n. No, because it's bound to the summation, so 1 to n.
Where's K?
K is the index. It could be an I or it could be a K. It's used differently. You don't need to write necessarily all down, but you do need F to be continuous, right, to be able to integrate. You need A to be partitioned by delta x if it's equally partitioned. C is just arbitrary. That might not be a bad thing to write down as well. Because remember, we do need to work with the definition of the integral. Okay, trying to give you guys enough time to get this down. This is Leibniz notation. Which is equivalent to the limit as n goes to infinity. There's another way of writing it, but this is one of the ways. N is representative of the number of rectangles. So you guys, when you were using 0 to n minus 1 in most of your summations, typically they do go from 1 to n just because it's easier. You can see that n is the number of rectangles, but 0 to n minus 1 also works. Sometimes it's easier. The general idea is f of an arbitrary c, delta x. Now, question, why is it okay for the c to be arbitrary?
What does arbitrary mean?
Means it can be basically anything within a subinterval. It doesn't matter as to which c. It doesn't have to be the left, doesn't have to be the right, doesn't have to be the midpoint, doesn't have to be the midpoint or the midpoint on the left side or the right side. What it is doesn't matter as long as the value in between. Why doesn't it matter?
Because they all come out to be approximations.
If whatever c you choose, as long as you're doing a finite number of rectangles, they're all going to be approximate, whether you choose the left or the right or the midpoint or some midpoint of the midpoint. They're all going to end up being approximations, but also if they all end up being approximations when they're finite, what happens when we get them infinitesimally thin and accumulate them over? What will happen to all the approximations as we include more and more rectangles? All the different approximations at whatever c you choose, as n goes to infinity within the finite interval, is going to approach the actual. So c is arbitrary. Now, why does the AP force you to use left or right or midpoint?
The contemplation.
They need you all to be following the same directions and be coming up with the same answer that they can check, right? But also, those are the typical ways of measuring, from the left or from the right or from the midpoint. That's just the different standard ways that you could go ahead and approximate. But truly, as you use the different approximations to approach the actual, it doesn't matter which one you use in the long run. Let me go ahead and move our attention really quickly to numbers 8 and 17. So they have the screen frozen, and so I'm talking in Fort Caroline's like, what? I'm thinking. Caroline, all that was about the page of notes, so you might want to go back and pause. They were taking notes on the first page of 6.2. Okay, number 8, they give you the function 2x minus x squared. We're just looking at the R ramp. 2x minus x squared. My interval is from 0 to 2, and I'm fitting in 4 subintervals. So I always think number line. If I'm fitting in 4, I would need to do 1/2 and 3/2, right? 1, 2, 3, 4. Good. So if I'm trying to do R RAM, first of all, for R RAM, guys, what are my bases for everybody? Good. So I can pull out a base from all of A1 plus A2 plus A3 plus A4. And if I'm coming from the right, think a table. I'm trying to make that 1 into a 1. It just did not turn out well. Like I was kind of talking about with Katrina, when you go up to make a rectangle, this first subinterval, it's been partitioned into different subintervals. This first subinterval, am I going to hit the curve at 0 or at 1/2 if I'm doing a right Riemann approximation? So I'm going to hit at 1/2. For the second subinterval, I'm going to hit at 1. For the third subinterval, I'm going to hit at 3/2. And for the fourth subinterval, I'm going to hit at 2. And so to finish this off, you just need to go ahead and plug 1/2, 1, 3/2, and 2 in, multiply by 1/2. And technically, if you're using your calculator, I would probably make this y1, right? And do 1/2 times y1 of 1/2 plus y1 of 1 plus y1 of 3/2 plus y1 of 2. And what's the shortest way to get to y1 on your calculator if you don't have a yellow button? Alpha. You could go bars, enter y bars function, or you could just do alpha and I think it's window. No, alpha trace.
For what?
To get the y1s. Alpha, you could do alpha y equals, then go to trace, or just alpha trace.
Okay.
But you have to put the function in your y1 or else it's not going to do anything because it doesn't know a y1. Alan, does that make sense?
Yeah, I think I just,
Plug it in.
Yeah. yeah, I did. Okay, I see what it is.
Number 17, let's keep it here really quick. That was the cardiac output, right?
Yeah.
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 Are you gonna be here after school? Like right after? Okay.
Oh, well that didn't work. Okay, cardiac output. I don't know why it didn't work. What you guys, or how did you guys, because you guys worked on this, how did you think through number 17? Gives us dye concentrations.
Yeah.
So you think of it basically just like a table, right?
Do base of 2, and then use mid, left, right, left,
You can use a base of 2 for every single one, since all of them are constantly a base of 2. So we can go ahead.
Probably the left open.
It didn't technically say, did it say how?
No, did it tell you from you?
Left or right?
Yeah, you could have done left or right or midpoint.
Right, now, so it's the left.
What some guys that were in here yesterday noticed is if you did do left, you would choose 0 and then 0.6, then all the ones down to 0.5, which is going to be the same thing as the right because it's going to be 0 and all the ones down to 0.6. So technically that's why they didn't make a big deal about it. Don't do the midpoint because you don't know the height at the midpoint, so that's impossible. So you would go ahead and just do 2 as your base, then you would multiply all of the 0 plus 0.6 plus all the way down to 0.5. And you're not plugging into a function because these are the values. So you know the x's and the change in is 2, but you're able to steal the y's because it's listed out to you in the table. But it was a little weird that they didn't actually state left or right or midpoint. I think they were just kind of assuming that you would understand, just choose one. The left ends up being the same as the right, and the midpoint is impossible. All right, so then coming back to your notes. Section 6.2. Is there anything new that we need to talk about? We have the definition of the integral. We have the delta x that only works when they're equally spaced. We talked about why c is arbitrary. And then the quick note that I wanted to make sure you guys got from this is that the function needs to be integrable. Integrable? I don't know, it sounds better than it sounds like integrity, and I just not doing it. Integrable. Integrable, is that integrity? I should know how to say this word, and I still don't. Okay. Lead notation, you guys know the upper bound, lower bound, the integral side, it is just an extended S for summation, or for summa? No. What's the Latin? I don't know, I think it's from Latin. The integral from A to B, and then we have the variable of integration, and you guys are good on the rest, yeah? The other way of writing the definition is one that I think we kind of saw briefly last year. It might show up again this year. I think it's a little bit further on the chapter, I just don't remember. You could also say the limit as, I think it's double line, x sub I. I think it's just x. Approaches 0 of the sum from k equals 1 to n of f of c sub k delta x. That's another way of doing it, because this one you're saying the partitions or the bases are approaching 0. It technically means the exact same thing, because as the bases approach 0, how many rectangles are you fitting into that finite space? Infinitely many. So this one says the limit as n goes to infinity, the limit as the number of rectangles fit or partition into the or into the interval approaches infinity. This one says the limit as the partitions themselves go to 0. So anyway, just a quick little letting you guys know. Let's keep going.
No.
Oh, I'm so sorry.
We have a minute.
Gabby, since you're close, do you think I could dual page it?
Okay. Thank you.
You're welcome. Cool kids, use a graph without your graphing calculator to approximate. Yes. Don't solve because you don't know how.
I don't, wait, we don't know how?
No, we don't. Because u would be 16 minus x squared du, or u prime would be 2x. There's no 2x to cancel out when you solve. Nope. You guys don't remember u sub either.
Nope. Like this.
What? We so do. What?
Actually, I remember you said that was the one thing from this I remember.
Nothing to remember.
I remember the exam.
How do you integrate that?
Then you have to
You
solve
solve
for
for
x.
x. Solve for x now.
But that's gross. I don't want to do this, Miss D. I quit.
I just said, you can't solve it anyway. Just trust me on it. You can't solve it by hand by integrating or anti-deriving, but oh, you can by area. It's half a circle. Thank you. Didn't we add that to basic math last year?
Miss D, this group's already working out for me.
Radius is 4.
Pause.
Pi r squared.
It is.
It's a quarter.
Someone like.
The graph is a half a circle. The area is a quarter circle. So my final answer is 1/4
Pi
pi
r squared.
4.
What would be the negative area?
So it's 4 pi.
It's a positive square root. If it was 0 to -4, then we'd have to say -4 pi. So we're going to keep an eye out for the square root of b squared or a squared minus x squared. Didn't we? I thought we had that to the basic graphs last year. I could have sworn it's on
A
the
circle?
It's
the semicircle.
no, it's not.
Y equals the square root of?
No.
I should make that something. I need to figure out our endeavors. I don't think they're up to date. We haven't really covered that many. Heroes. Let me go ahead and zoom in on a single page. I just want you to see what they're trying to explain. Trying to show you that different textbooks portray different concepts different ways. A lot of what I showed you last year wasn't directly out of the textbook. It was kind of more my teaching. Does it make sense that the integral from A to B would be the area above the x-axis minus the area below? Yes, because what they're saying is area is technically always positive. You assign the negative when you're dealing with it, and it's below. Alright, cool kids, I'll see you later. This section will go ahead and finish on Monday. We'll do on Tuesday start homework for Monday. Show me that your new group is inspiring excellence by starting your homework.
Yeah, I will.
Bye, guys.
I'll start my homework, finish all my other homework, so that's. Oh, I need to go buy my ticket.